Azra Raza wrote an amazing book called The First Cell, which is her story of being a cancer researcher at Columbia University and dealing with actual patients and struggling with the broken cancer research and medical system. We had a wonderful interview, and join me as you hear this amazing, fascinating story. I was quite surprised that you knew who I was.
Can I tell you why I know you?
Yeah, please.
Number one, you became very important for me because you acknowledged two women who have been my heroes, Barbara McClintock and Lynn Margolis.
Oh.
And when I read your book, Evolution 2, some years ago now, I felt sort of a kindred spirit, because it is a brave thing that you came out to say. You are kind of bridging that gap between intelligent design and Darwinian evolution, and that requires a lot of courage to be able to say that and not be slammed as a maverick, as someone who doesn't know what they're talking about and things like that. So you became very...
Oh, wow. Well, that means a great deal to me. You know, I have rarely seen any areas that are more fraught with bad blood and vicious, you know, talk and everything like that. And when I have to tell you, when I discovered Barbara McClintock, I'm like, why isn't this woman on the first chapter of every evolution book? Because in my opinion, and I'm recording now, let's just go, all right? Yeah. In my opinion, what she discovered is more functionally useful than what Darwin discovered, because she figured out how it actually works. He didn't. I mean, God bless the guy. And I was just at his estate 2 months ago, and we shot a little documentary with some voices from Oxford people, and it was great. But all Darwin did was give us questions. He didn't give us any answers.
Yes.
So
and he gave us a lot of converts too, who are just making up all these things and defending the neo-Darwinists.
So I didn't even realize that we had that in common. So this is like the perfect introduction to this conversation. So we're already going. So my guest is Azra Raza. She wrote a book called The First Cell, and it was recommended by James Shapiro, who is a bacterial geneticist at the University of Chicago. And so I picked up the book and I read this book, and I was like, my goodness. Okay, so this book is a cancer researcher whose husband died of cancer, who trained her in cancer research in the first place. So there's a very kind of weird synchronicity with that. It is disarmingly honest. It is also very personal, and it's also a little bit like reading Rumi. It's like there's this poetic element to it. And so, and your name came up in a few conversations. I thought, well, I wonder if I could get her to come on my podcast. And I reach out, and then she goes, well, actually, I know who you are. And I was astounded, because most medical people working in New York City would never possibly know who I am. So here we are, Azra, and I'm delighted to be talking to you. I want to get you talking about your book a little bit, and maybe for a little bit for you, this would be a little bit of predictable conversation. But once we kind of get the nature of your book out, I've got some questions for you that I think are going to be very interesting. So I saw an interview where you were asked, well, what was the genesis of this book? And you talked about a 22-year-old who was a friend of your daughter. can you tell my listeners what happened with that?
Thank you very much, Perry, for having me. First of all, let me say what an honor it is for me to be meeting you, because I've been a great admirer of your very unique and revolutionary way of thinking about evolution, a subject I have been obsessed with since as long as I can remember, probably 10, 11 years of age. So I keep reading in this area tremendous amount, and one of my heroes is, as I told you, Lynn Margulis, who also stood the whole field on its head by saying evolution is not from just competition but cooperation.
Yes.
And then Barbara McClintock, the Nobel laureate, who introduced the concept of transposons. And I remember when you first contacted me by email, I wrote you back saying, is this a hoax or is it the real Perry Marshall? Because I've been reading you for so long. And then you sent me saying, no, it is the real one. Here's my books and, you know, things you tried to prove yourself. So I'm really delighted to be here. And thank you for asking me to begin with talking about Andrew. What made me and forced me to write this book finally, despite the fact that I have been a practicing oncologist, seeing 30 to 40 cancer patients every week for practically 3 decades already, and and have also a research lab. So I have been conducting basic research in cancer for as many years as well. And I'm one of those people who do translational research, which is try to develop biologic insights in the lab, bring them to the bedside for improved treatment. And the third thing, as you said, is that I'm a cancer widow. But none of those things had forced me to become an author. Wow. Until I was faced in 2016 with my daughter's best friend, not her boyfriend. Andrew was gay. Andrew was in and out of my home since the two were 15 years old, and they had just entered high school together. And this beautiful young man one day feels numbness and weakness in his arm, and he's taken to the emergency room. And within hours, he's quadriplegic. And the neurosurgeons who operated on him found a 9-centimeter big tumor, brain tumor, which was unresectable. So from this point on, Perry, every treating oncologist and surgeon knew that the vicious glioblastoma multiforme, one of the most malignant, malevolent tumors known to mankind, in stage 4, 9 centimeter, nothing we do will add 1 day of survival to this poor boy. And on the other hand, when he opened his eyes after the surgery, he was told his diagnosis, and he confidently turned to his mother and said, "Mom, don't worry, just call Azra. She's on the cutting edge. She will find the cure for me." And this slapped me in the face, Perry. This 22-year-old beautiful young man diagnosed with such a horrendous cancer, and the levels at which I was going to fail him now until he died graphically stood out for me. And after living through that experience, I had to put it down and question, why are there so many misconceptions about cancer? Why have we failed the Andrews of this world so spectacularly? And why are we failing to develop treatments for this disease? Despite $250 billion invested in basic research, why are we still using slash, poison, and burn?
Well, and there you go. The whole book is like this. And it's just this story after story, but then it's interspersed with the clinical and the medical and the biological perspective. It is just so disarmingly honest. I mean, my goodness. Okay, how have your peers received this? Like, you have called out the elephant in the room in the cancer business, and you know, all of your colleagues, like, they got to get funding and they've got to get research paid for, and how are you a black sheep? Do they like it? I mean, how has it been professionally for you?
I think you're asking a really important question here, because unexpectedly, Perry, it has not been slammed the way I was dreading. Because as you say, I ask, why the gridlock? Why are we not moving beyond this slash, poison, burn? And in many ways, and in many uncompromising ways, I have indicted every level of the cancer paradigm as it exists today. Because at every level, somehow it comes down to what in very gross terms is called paycheck oncology. So yeah. I was thinking that everyone and their grandmother is forever going to hate me. But I suppose I've been a maverick in the field for so long as an outsider. I'll tell you why I say that. Well, first of all, imagine that I'm a woman, I'm colored, I'm an immigrant, I'm a Muslim. I come to America to cure cancer. I mean, and then I refuse to play by the rules that have been laid down here.
Yeah.
The rules are that when I came here, I started to study and treat patients with acute myeloid leukemia. But within 8 years, I realized, and I'll read a little thing to you about what I realized and what made me understand why this disease is so complex that in my lifetime, we won't be able to cure acute myeloid leukemia. And sadly, I was right, because today in 2020, we are using the same 2 drugs we were using in 1977. With the same dreadful results. But I decided we should try to find this cancer early. It's our only hope to try and find it at the pre-leukemia stage, and instead of hacking at the leaves, try to go for the roots. And if I had gone to school in this country, I would have done what all my peers were doing, which is to make an animal model of this disease, which are completely artificial and just do not represent what is happening in the human at all. But luckily, my being an immigrant helped me, and instead of following tradition and custom, I started saving samples on patients, and today I have a tissue repository of over 60,000 samples saved serially on patients as they traversed in their journey from pre-leukemia to leukemia, which goes against the grain of everything that was being taught. The only grants that are being given are to mouse models and to animal models, and people who are studying human tissue are the pariah in the field. But luckily, I was able to do this, and so I have been like an outsider for a long time. Still, writing this book made me nervous that I would be met with a lot of negativity. Surprisingly, there hasn't been overt negativity, only because no one can argue with the basic essential hypothesis of the book, which is the only strategy that has worked so far is catch cancer early and try to get rid of it early. And all I'm saying is, let's go really early. Instead of always chasing the last cancer cell, let's come to the first cancer cell. So they can't deny it and they can't slam me.
Wow. Well, I guess I mean, I've watched Mavericks, okay, in evolutionary biology, okay, and in evolutionary biology, complete truth tellers who have immensely thorough work have still get insulted, and people say that they don't know what they're talking about. So it's not inconceivable that even with all of your proof that you know, somebody wouldn't just denounce you or mischaracterize. But wow, so truly, like, you haven't been slammed by anybody?
I'll tell you, I think one reason is that I look at everything that I've written, even the most controversial things for the field to digest, is all through the prism of human anguish. So it is very hard to really argue with me and say that we are making great advances and keep thumping themselves on the chest and giving each other all the perks the fields have to offer, and congratulating each other on wonderful advances, but in mice, when humans are suffering so much.
This is just so disarmingly, refreshingly honest. My goodness. You know, I have a friend, these two friends, Bill and Laura, they're both about 60, and she found out she had pancreatic cancer in November, I guess, or December, and they're already well down the road. This is like not going to very well. It's pretty predictable. And when I read your book, kind of my gestalt impression was, good grief, so what's the use? Are we, okay, are we being valiant or stupid? And is a cancer treatment for most people just $500,000 of hand-wringing?
So let me just make one distinction here, Perry, which is that we are curing 68% of cancers that are newly diagnosed today. 68% are cured.
Okay.
Whether it is pancreatic or whether it is colon or breast, any of these. You know why? Because if they're diagnosed early. But the 32% that are diagnosed at an advanced stage, their outcome is no different than it was in 1930. So the idea is, if you can catch cancer early, you can try to cut it out and poison it with radiation or with chemicals, and that's the only thing that's working. Since the war was declared on cancer in 1971 by President Nixon, $250 billion have been invested to develop better therapies. And save for a handful of things which help maybe a few thousand cases compared to practically 1.7 million patients, we are still using the chemotherapy, radiation therapy, and surgery to treat. And for a third of the patients, like I'm so sorry to hear about your friend, and like Andrew, we have nothing to offer them.
So, because I'm a business person and a consultant and an entrepreneur, I completely understand paycheck oncology because there's a system, right? And so, like, if people have a job and they get paid to do a job, then when presented with an opportunity to do their job, they're going to do their job, right? They're going to do what's been defined for them to do. And it's like, well, okay, so we have an oncologist, and we have a radiologist, and we have a doctor, and we have a nurse, and we have an office, and we have a hospital, and the thing just runs a certain way. So, Azra, if you were going to, let's say you're going to like you're going to build a clinic from scratch, on virgin soil, and you're going to hire whoever you want to hire, and you're going to staff it however you want to staff it, and it's going to be Azra's Cancer Clinic. And if you could rebuild the cancer business from the ground up the way that you want to, what would you discard? What would you keep? How would you do it?
Excellent question. Here's a very straightforward answer. All cancers begin in a single cell, and then they start mutating, and as they divide, they become more and more complex. Because, as you know, there's random mutations, then there's natural selection, environmental influences, and we have give them enough time and they become basically a new species. So a cancer, as it keeps dividing, becomes 1,000 different cancers within a few generations. So we are not dealing with one cancer. Very quickly, we are dealing with thousands and thousands of different types of cells. So that has become very clear over the years. And what is sad to me, Perry, is that back in 1977, I reviewed the paper by Peter Noel presenting exactly this whole notion of clonal selection within a tumor. and its clinical implications. This was back in 1976. The clairvoyance is amazing. All we have done in all these years is by using fancy, sophisticated genomic analysis, proved him right by showing that, yes, there are all these mutations that exist. So if I'm given unlimited resources and I'm asked to restart the whole cancer field, the first thing I would insist upon is that magic is not going to cure it. We need science. We needed to develop the technology, and we need to continue to refine technology, but use the technology on the right tissue. Why do we keep studying animals? Yes, it's giving us a great understanding of biology. I know that. But that biology has not improved the outcome for patients. So then to me, it's useless. Then what biology will help patients? Study patients' own tissue, because think of it. Cancer starts in a cell, but it needs nutrition. So it starts attracting blood vessels to it. It starts dividing. It starts shedding its markers, its surface proteins. It sheds into the blood, sweat, tears, saliva, urine, stool. Everywhere it's shedding. Why haven't we looked seriously to find the footprints of cancer? We know no age is immune, because poor Andrew, there were no high risk factors for him. Why did at 22 years of age he gets diagnosed with extensively advanced brain tumor? So no age is immune. Cancer is a silent killer, because it reached 9 centimeters before he even became aware that something was wrong, and then within hours he was quadriplegic. So given how quickly it can creep upon you and how silently it expands within the body, it's clear that we have to monitor the body continuously for signs of appearance of cancer before it becomes advanced. Because anything we give in terms of treatment, be it slash, poison, burn, or be it targeted therapy, or be it directed against genetic mutations producing abnormal protein, everything will work better if it's less complicated. We know that. So what I would do if I was going to restart is study only human tissue for development of human biomarkers and footprints of cancer. I would bring all the technology available to start using this right now. We have cancer patients now. I would treat the cancer patients with whatever targeted therapy or whatever treatment we are giving, because a certain percentage are responding. I would study them so thoroughly using all the panomics, genomics, transcriptomics, metabolomics, and proteomics to find the distinguishing marks of patients who respond versus who don't respond. And then each time we develop the next stage of the trial, we use those markers to pre-select patients who are likely to respond. And this is how we, but we have to study humans directly at every step, whether it is for diagnostic purposes or monitoring treatment outcome or developing better treatments. And I would use all the technology, artificial intelligence, scanning and imaging devices to bring to bear on only this one thing: early diagnosis, early detection, prevention, and early treatment.
So talk more about, so are you saying we're going to do all this stuff before they even have cancer? Like we're the proteomics and the metabolomics and the, is that what you're saying?
What I'm saying is that we need to constantly, you see, right now, the way we screen for cancer is that annually after a certain age, we'll do colonoscopies or mammograms or PSAs or check for pap smear. I'm saying that misses a lot of people, so that 40% of women, despite having mammograms and the screening, 40% today are presenting with advanced breast cancer, and their outcomes are horrible. So why is that happening? Because we are missing cancers by mammography, but that doesn't mean that early detection is not working, it means mammography is not working. We need to develop better techniques to find those breast cancers early. So basically, my proposition is that first we study the current cancer patients, we are treating them, we try to understand why are some patients responding and others are not. We try to benefit the current patients, but for the future patients, we develop techniques to start monitoring them from birth onwards for the appearance of the first cell of cancer. And that's very doable, very possible, Perry. I'll give you one example. You can go to sleep in bed sheets that scan you overnight for the appearance of the cancer. How? Let's say your friend you just mentioned with pancreatic cancer. I told you all cancers need to increase blood supply to the tumor. So that area becomes hot. That heat can be picked up so that bed sheets can find an area in the abdomen, in the area of pancreas, which is looking hot. It doesn't mean that the person should wake up the next morning and have an open abdominal laparotomy and evisceration of every organ. What it means is now there is a region of interest that we need to monitor very carefully. So now we target on that area, we follow it and monitor it to see, is it growing? Is it really there? If it's growing, what else is it shedding? And then we start looking in blood and urine and saliva and every secretion possible to see, can we detect any telltale signs of this cancer, any biomarker? Those are the biomarkers we have to find. So once we find that, once we have an area of interest, we find that it's coming from the pancreas. Now, is it going to be a potentially lethal one, or is it a benign tumor? For that, we also have biomarkers. Methylation signatures are coming out showing where this is coming from and whether it's going to be aggressive or not. So I think all of these things have to be done together, but there's no, it seems like literally that there is no adult in the room planning anything. It's like knee-jerk things. If somebody finds a checkpoint inhibitor kind of immune therapy, then 3,000 clinical trials from sponsors, each trial costing $100 million, are going to try and compete with each other to get a drug approved, which will improve survival for a 20% patients by 5 months at most. But the company will end up making $1 billion a year. So there's just no control over these things. Nobody is looking at the field in a proper perspective to try and really help the patient. That's what we are forgetting, patient.
So Azra, let's imagine for a second. So we're gonna start the Azra Hotel, and it has thermally sensitive sheets that if you're over the age of 45, you go spend a night in the Azra Hotel, and while you sleep, the sheets are going to monitor the temperature that might indicate extra blood running to your pancreas and whatever. And then if there's anything that comes up, then you're going to have this hyper early detection regimen that you start running things through. It's like, okay, you've got 25 cancer cells in this like little area right here. And fortunately, this is not stage 1. This is like stage 0.7. And we're just going to nip this in the bud right now. Would that work?
Yes, perfectly. Because the same things, many of the targeted therapies that are not working, we can direct them using the biomarker to give them the address where to go and specifically act. Or we could use a laser beam to burn those cells rather than giving 6 weeks of a horrifying radiation therapy. So the treatments would be much simpler, Perry. But the key is to find, you see, the biggest challenge is, I think we've been underestimating the enemy constantly.
Oh, heavens. Yeah, really, let's talk about that. Tell me.
And I wanted to read why your ideas appealed to me so much. If you don't mind, I'll read a few lines from my book.
Yes.
Okay. Treating cancer as one disease is like
Oh,
treating
you covered up your
Africa.
microphone a little.
Oh, can you hear me now? Okay. Treating cancer as one disease is like treating Africa as one country. Even in the same patient, it is not the same disease at two sites or at two different points in time. Vicious and self-obsessed, it learns to grow faster, become stronger, smarter, and more dangerous with each successive division. It's a perfect example of intelligence at a molecular level, able to perceive its environment and take actions that maximize its chances of survival. A feedback loop using past performance to improve its efficiency forms the basis of its seemingly purposeful behavior. It learns to divide more vigorously with time, invading new spaces, mutating to turn on the expression of pertinent genes off and on, enhancing its fitness to the landscape, optimizing the seed-soil cooperation. We see this metamorphosis in front of our eyes when treatment causes regression of the tumor in one area, just as fresh lesions crop up in another, bearing novel genotypes selected precisely because of their refractoriness to the administered therapy. As mini Frankensteins, they emerged like ghosts from the machine, bent upon destroying their maker. This is why your idea of evolution too jives so well with me. Because cancer cells are not dumb cells. They have somehow co-opted the whole machinery of the cell to serve their purpose and have gone rogue in that sense. Trying to understand each and every signaling pathway inside these cells and try to unravel the mechanisms of evolution in this cancer cell and its progeny is going to take a long time. But in the meantime, we have problems to solve. So while we try to understand that through, I don't know, whatever mechanisms we want to apply, in the meantime, to help patients, all we can do is diagnose early and try to treat it early. So essentially, it's not that this is not happening, and it's not as if I'm the only one saying it. All along, we have known that early detection and early intervention is the only thing. It's not cancer that's incurable. It's delay in treatment that makes it so. So that there are people, but my problem is that at the funding level, only 5% of the money is going towards early detection and prevention. So, for example, recently, Toshiba, the Japanese company, announced that from one drop of blood, within 4 hours, they can diagnose 12 cancers early, based on just microRNA signatures that they have developed for $180. That's it. So you can be at home and once a month you can use a drop of blood to look for the 12 biggest killers.
Wow.
What's wrong with, why can't we monitor starting from childhood onwards like that? But even more importantly, big group at Johns Hopkins, Dr. Bert Vogelstein, their group announced something called Cancer Seek. They can detect 13 cancers based on proteomics, but also the company that is called Grail, dedicated to early detection of cancer, they announced that they can detect 12 cancers from blood using methylation signatures and presence of cell-free DNA and cell-free nucleic acids. So it's not as if this is not coming. It is going to happen. In fact, the decade 2020 to 2030, I'm so optimistic and excited about it because this is the decade of early detection and prevention. This is the decade where medicine is going to turn from treating disease to preventing disease. And cancer is the biggest challenge we have right now where this has to happen. For the reasons I just read out to you, that evolution too, which means that an evolution where there is literally there is an adaptive mutation rather than a random mutation. Why it happened, we don't know. But what is making the cell so intelligent is because it is able to behave as if it is an intelligent design. And that's what it's used to doing. So the same normal machinery that is the strength of the cell turns against it in cancer. And the only way we can handle it right now to save lives, I'm not talking about knowledge. Yes, we should gain knowledge and understand all of those things. But in the short run, let's make a beeline for early detection.
I just want to give you a big hug, because the passage that you read was the passage I was going to read to you. Like,
oh,
I mean, I had it ready to go. I didn't know you because that is exactly right. In fact, let me go back to what you said, because let's take this line by line. A feedback loop using past performance to improve its efficiency forms the basis of its seemingly purposeful behavior. I say it is purposeful. Don't even say seeming. It is purposeful. It learns to divide more vigorously with time, invading new spaces, mutating to turn on the expression of pertinent genes off and on, enhancing its fitness to the landscape, optimizing seed-soil cooperation. That's exactly right. In Evolution 2.0, I said, cancer is evolution run amok. Cancer and evolution are synonymous. And now, you said a feedback loop. Now, 100 years ago, August Weismann, he created this thing called the Weismann barrier, and he said the information only flows one way, and then that was further reinforced by something called the central dogma in biology. And we now know both of those are false.
yes,
And
DNA,
what that
RNA, protein, yeah. Mm-hmm.
and what that does is, what they said was it only moves one direction, and you said no, it's a feedback loop. And so those cells are listening, they're watching, they are responding, they're smelling, metaphorically speaking, of course.
Yeah. Mm-hmm.
And they're responding to everything. And so like a phrase that comes to mind for me is like the cancer Cambrian. In evolutionary history, you have this sudden emergence of rapid speciation 500 million years ago, and this is exactly what happens when you start to bombard cancer with radiation. It mutates. I tell my friends, if you want to understand cells and evolution, they're just like little entrepreneurs. All of us guys, like, oh, there's a coronavirus, and all of a sudden the restaurants are shut down. Okay, then we're delivering. The coffee fitness place down the street is renting out their barbells and their dumbbells, and they're doing live stream exercise classes because they have to stay alive. It's like, this is what cells do when you're trying to kill them with radiation. And so, yeah. And until we understand evolution, we're never going to solve cancer. And they're still teaching evolution wrong in all the textbooks.
Yes, I couldn't agree more with you. This is why I began by telling you that I knew and read your book and was so fascinated by it, because I do. Now, here is a little bit of sexism, not a little, a lot of sexism in the field, that Lynn Margulis was told over and over that her idea of symbiogenesis is crap. Her original paper was rejected from 15 different places before it actually made it into publication. You know that. So that, and Barbara McClintock also, the jumping genes, I mean, that feeling for the organism, what a beautiful book she wrote. But look at how long it took her to be accepted. And this whole community of scientists who are like lemmings behind this neo-Darwinistic thing, combination of Gregor Mendel and Darwin, and insisting that random mutations affected by environment or microenvironment or whatever given time will produce speciation is the only way to go, the central dogma of evolution. Although these two women alone showed why that is so such a misconception, because there can be horizontal transmission of genetic material, as McClintock showed, and as Lynn Margolis showed that organelles inside the cells were independent living organisms, whether they're mitochondria or other organelles, so many of them. But they are not accepted and not taught as parts of evolution even today. Only Darwin is taught.
Well, so what I love about the first cell is that, especially towards the end of the book, you go after the reductionist conception of biology that, oh, we're going to figure out fill in the blank, like we're going to figure out the thing, and it's never the thing. It's eluded us for 40 years.
Yes, arrogance, hubris, overconfidence, contempt. These are all the reasons why wave after wave of young researchers keep coming on as if the past doesn't exist, claiming that they will learn the next intracellular signaling pathway. Oh, you didn't have the molecular techniques. We have now to manipulate this or that. I mean, the hubris has been a serious impediment to developing better treatments. But even now, Perry, no one is willing to take off the blinders and see the problem for what it is.
So what would it take, just imagine with me, indulge me, what would it take for you to go set up the Azra Hotel where we can detect cancer at stage 0.7? Like what kind of money, what kind of resources, what would be the smallest prototype version that you could put together and show the world? What would that look? Just speak freely.
Perry, the thing is that we need to study each cancer very carefully with all the latest technology. But we need to study tissue. Who has collected tissue? Thankfully, in 1984, when it became apparent to me that acute leukemia is too far advanced to be cured, and I turned my attention to pre-leukemia, I started saving cells on my patients. And today, I should really somehow be able to convey to the public what it means to have this tissue. Can you imagine? I have 60,000 samples today in this tissue repository, Perry, and not a single cell comes from a second oncologist. What does that mean? I have taken care of every single patient myself. I have walked 90% of them to their deaths. And they were so noble and such grace in saying, Dr. Raza, even if it doesn't help us, take our bone marrow. It's a painful procedure, and drawing extra marrow and drawing it repeatedly means that they bore this pain and suffering only to help me, help other patients, make it possible for me. How humbling is that? The nobility of their endurance and of their purpose. Then no one supports even the maintenance of such a tissue repository. So first, the pain we cause patients from the moment I open the tray, which I use to perform the bone marrow, the needles I use, I have to pay for everything because it's considered research immediately. Now, to pay for it, there are no grants available. To put it in a freezer, there is the space, I have to pay for everything. So who pays for it? My patients again. My benefactors, I hold fundraisers, people who are philanthropists, friends, family, patients, they are supporting the tissue repository. So for 35 years, I have been consistently performing the bone marrows with my own hands, even today, and saving these cells. Now we have this tissue bank, at least for pre-leukemia to acute myeloid leukemia. You know how many times I've written about this to the National Cancer Institute, asking them to help me study the samples, and how many times I've been turned down? Of course, I keep going in, pulling out samples and studying when I get grants, but that's asking to study one signaling pathway or one gene, and then I publish a paper in high profile journals. But do I need another paper in Nature or New England Journal of Medicine? Of course not. What we need is to study the whole tissue repository with all the techniques available and study the patients repeatedly and serially in a longitudinal manner as they progress through the natural history of their disease from pre-leukemia to leukemia. This will cost a lot of money, like $4 million just to study 200 patients for proteomics alone. So that kind of money is not existent, non-existent anywhere. Who's going to support it? But we have to do that to understand the biomarkers that are needed to trace back to why some healthy individual, first of all, got even pre-leukemia, and then start to monitor using those biomarkers. So when you ask me what will it take, for each cancer, pancreatic cancer, ovarian cancer, lung cancer, colon cancer, prostate cancer, for each of them we need to have these biomarkers identified and trace them back to find out why did a healthy individual was at high risk for getting this type of cancer versus that. And then monitor those high risk individuals for the presence of the kind of cancer we suspect they are likely to have. So to develop all this means serious scientific interrogation, investigation, and relationship of finding the associations between biologic biomarkers and the natural history of the disease, the response to therapy, what is happening to these patients. It can all be done so quickly as soon as we financially incentivize and set the new goal. As long as money is available to do it, people will rush. But the only problem will be for other people, they don't have samples. I have the samples. When people ask me, Dr. Raza, why should we give you money and not American Cancer Society? I say, show me the samples for American Cancer Society. They don't have it. So I established the first cell center at Columbia University where I work. And all I need is just, one of the things, Perry, is that cancer is I don't want to scare people, but individuals who have had one cancer and who have survived it are at high risk of getting a second one, because 1 in 5 new cancers occurs in a cancer survivor, just like Harvey, my husband. He had the first cancer at 34 years of age and the second one at 57, from which he died. And they were 2 completely different cancers. So there are now about 17 million cancer survivors in the country. They are at high risk for cancer, and they are the ones who should be most interested in finding the first cell. I'm saying if even 1 million of them give $10 a month for a year, that's it. That will be enough to study the tissue repository. And then all the techniques are there. We have all the clinical data. We have all the tissue. We have all the techniques. We need the funds to study. We'll find the biomarkers of interest. We'll find amazing, unexpected things even. And that's the way every single cancer has to be studied. And then it can all be put on a chip. The biomarker for pancreatic, for ovarian, for leukemia, for lymphoma, they can all go on one chip like a barcode of proteins. And with 1 drop of blood a month, sitting at home, you can use this chip in your own cell phone to find whether there is appearance of a biomarker indicating the presence of a cancer or not. This is not a pie in the sky. This is all going to happen anyway. But it's going to take longer unless we put in the resources.
So you think like you can start this with $4 million?
Yes, or absolutely.
Wow. That's fascinating. That's really interesting. Wow.
And imagine that it's somehow, I feel it's really shocking to me that in this country, where they can pay a football player $120 million, they are not willing to invest a few $1 million in. Do I have to establish my credibility anymore? I mean, I've been completely devoted to this, but I keep groveling in front of everybody to give me a few. I mean, this is talking about curing cancer, for God's sake. 1 in 3 people will get cancer. Why are we taking it so lightly? And because, somehow in the public, there's this delusion has been created through these smoke and mirrors that great advances have occurred in cancer treatment. It's all curable. It's not. This is why I want to take the blinders off and let people see the truth, that even those we are curing, the 68%, we are curing with draconian, horrible treatment, like taking baseball bats to hit dogs to get rid of their fleas. That's how horrible that treatment is. Why are we using these Paleolithic, Stone Age, cavemen therapies in this day and age?
Oh, man. Preach a sister. Wow. Well, this makes so much sense to me. This is just so congruent. Well, it's congruent with 2 things. First, it's congruent with all the biology that I've learned, because I came into this as an outsider, like, this is going to have to make sense to me somehow. And it doesn't right now, right? So there's that. But it also makes sense socially with the way that systems get corrupt. There's a funny book called Systemantics. It's probably 20, 30, 40 years old. And it's a very cynical book about how bureaucracy works, basically. And it says, the system never does what the system says the system is doing. The healthcare system is not about healthcare, and the education system isn't really about education. And so, and it's true. And it's almost like if once you recognize that, you've taken the red pill.
Yes. And I want you to know that the book I have written, everyone says, oh, it's a book about cancer. No, it's about cancer patients.
Yes, and it's beautiful. I mean, it is, well, it just like popped into my mind. I remember 6 or 8 years ago on Facebook, there was some woman who had her breasts removed. And I don't even think she had nipples anymore. And she appeared on camera topless. And she said, this is what's happened to me. Well, because of the disfigurement, it wasn't pornographic in the slightest. It was not inappropriate to put on Facebook. But I remember seeing the comments, oh my word, I can't believe that woman's willingness to be vulnerable. And of course, there's something very empowering if you've been through something like that, to see a woman with that kind of courage. And that is what your book feels like. It is. I am an oncologist. I am a cancer research, and I have stripped myself naked, and I'm telling you what this industry is really like, and I'm telling you what it's like for the patients.
Well, thank you for saying that, Perry, because, let me just say one thing about Andrew. At 22, he's diagnosed. 16 months later, he's barely 23, and he's dying. And before he died, 3 weeks before, they brought him in the hospital, these forms to sign that are called DNR forms, do not resuscitate. That means if he has an arrest, they are not to bring him back to life. 23-year-old, he sent them back. He said, I'm not going to sign them, take them away. They took them away. But that night, his father came to spend the night with him. And he called the attendants back and said, bring the form back, I will sign it now. And you know what he said, Perry? He said, I couldn't sign them in front of my mother and sister. They wouldn't be able to take it. This is what we are talking about. This 23-year-old boy is protecting his mother as he lays dying. Why are we not doing better for someone like Andrew? This is the question that keeps me up at night. And this is the question which, as a society, we need to address now. Because at some point, individual responsibility ends and society's responsibility begins. No man is an island, an island in itself. Each is a piece of the continent, part of the main. Any man's death diminishes me because I am involved in mankind and therefore never sent to know for whom the bell tolls. We are all interconnected. We are in this together. There is no one for whom cancer is more than a degree away. But imagine a mother whose only son is dying this painful death and the oncologists have nothing to offer. We should be ashamed of ourselves. And we should try to imagine a better future for Andrews of tomorrow at least.
Well, let's stop trading our dreams for small desires.
Thank you, Perry.
Well, thank you.